Right. We focused on STP, types of STP. We even did a couple of labs in the common STP, per VLAN STP, and we also saw how to change the root switch and port roles by changing the priority or by giving the command primary and secondary. I also showed you what happens behind the screen when you configure primary and secondary. We also had a very good introduction on a rapid spanning tree. We are going to revise once and then we'll get into the lab. The difference is rapid spanning tree IEEE 802.1W. It's not same 1D standard because this is totally different, right? So it cannot be in the same document. This IEEE 802.1D, what does that mean? It means a document's reference number. Reference. Right? So this is another document. IEEE is another document coming under 802. That subsection is 1W. Right? If you take laws of different governments in different continents and countries, you will have laws with number and then subdivision in the law will have a 1A, 1B, 1C, 2A, 2B, 2C. Same way. These industry standard documents also have got numbers to identify. So when you go to Google and type 802.1W, you will find rapid spelling trees document. Google. No, I don't know whether we will be using the word Google after 5 years. Today, Google is the only hope. For many years, Google was there as a search engine. Still, it is there, but slowly something else is coming. Nowadays, few people started searching on ChatGPT. And slowly, every country wants to have their own search engine. China had got search engine even 10 years, 11 years back, their own search engine. They never used Google. They never used Safari. They had their own. So we are always behind the schedule. Now, the purpose of rapid spanning tree is fast convergence. The reason is it is not timer based. It can converge faster. The classical one is slow. It takes approximately 30 to 50 seconds. Rapid spanning tree, you see, the BPDs are sent by every switch every 2 seconds. As soon as the primary link fails, immediately the switch which is undergoing that failure, that link failure, will shoot out a BPDU with a change info that makes the other switch which is maintaining a blocking or alternate port to unblock it, make it forward. That's a very big advantage. It's not only the root switch controlling everything. Every switch can initiate the change for the path by sending the topology change notification. Whereas in the classical IEEE 802.1D, root switch will not be able to send the BPD because of the link failure, and no other switches are eligible to send the BPDU. So they all will wait for 20 seconds after the timeout happens. Then they come to a conclusion that something went wrong. They do the rediscovery of topology and then they find another primary path, another best path. It takes around 50 seconds. All right. And then every time the root switch needs to time out to take a decision. So every time there is a need for listening, because only the root switch is eligible switch to control others. See, why every time this common STP need to listen? Because now the only one who was knowing the topology, who was sending the BPDU, is no more sending it. The link is failed. So now BPDU which is supposed to come is not coming because the path is broken between the other switches and the root switch. Now that the other switches will wait for the timeout to happen. And then only they will start trying to discover the new topology after the link failure. So they have to listen every time. So in the listening state, they wait the common STP switches, they wait for 15 seconds and then learning another 15 seconds. And then what they do learn here is they learn the new MAC addresses for this newly elected path, and then the forwarding. So these many states are there: blocking, listening, learning, and disable. If you shut down, it will be in a disabled state. Whereas in the rapid spanning tree, you got only 3 states. Discarding, meaning temporarily it is not going to forward, which is nothing but an alternate port. It will discard the packets. Whose packet? The user traffic, not the BPD. BPDs are sent and received even on the blocking port. I told you long back. I told you. Right. So learning, it's not a timer based. As soon as it learns the BPD with new topology change from the close by switch or from the directly connected link, when it fails, immediately changes the state from discarding to forward. So less than 25 seconds. Sorry, less than 2 to 3 seconds. Why the number 25 came in my mind? Because in one of the document in not in Cisco, in one of the document in another vendor. Wait a minute, I'm trying to recall the name. HFCL. HFCL is one of the Indian-made routers and switches company. Like Cisco, HFCL is one company. The headquarters, I think it is in Gujarat. They have a big office here in Embassy Tech Park, Bangalore, in Martali. So when I was teaching them, I saw their internal document, one of the internal document they have written there. The convergence time is 25 millisecond. This rapid spanning tree, 25 millisecond. I don't know how they say that, but it was quite attractive for me. See, 2 to 3 second and 25 millisecond, big difference, you see, very big difference. 4-5 times earlier, faster than what this document of Cisco says. So whatever. That is why the number 25 came in my mind. 25 millisecond convergence time. I have not tested it, but I just read in the HFCL document. Have anyone heard about HFCL? So rapid spanning tree, if you see, we have root ports, same like a normal STP, the non-root switches will have a root port and then a designated port. So the non-root switches will have one root port and will have designated port. And root ports will have designated ports. All ports are designated to forward. And then you will have an alternate port, which is also called as a backup port. You know what meaning it is. It's not currently forwarding, it's discarding. That's what called as alternate port, which will act as a backup if the designated ports or a root port goes down. And here in common spanning tree, based on the timer only, the role change happens. First, the BPD should time out, and then 15 seconds of listening should time out, and then 15 seconds of learning should time out, and then only the role change happens. Port state changes only after the time gets expired. That's not the case with rapid spanning tree. Rapid spanning tree is handshaking, meaning every router will intimate, send a proposal saying a link has went down. Shall we do a recalculation, path calculation? That's what proposal. And the switch with the alternate port agrees on it and makes the alternate port as a forwarding port. Yep. So next is this IEEE 802.1d is compatible with older STP, which we don't have in any switches now. And now this is rapid spanning tree is compatible with common STP. One switch you are running rapid, another switch you are running common. Will they work together? Yes, they do work. But how they work? They will work as a common STP. Though you have enabled rapid, it will work as a slow common STP. So what I'm trying to say is there is a backward compatibility with the common spanning tree. Rapid spanning tree has backward compatibility. And you know about this failure, this is slow and this is immediate. I told you 25 millisecond or 2 to 3 seconds. And here, if it is per VLAN spanning tree, it is per VLAN separate instant of STP. Same thing here also. In Cisco, when you enable rapid spanning tree, the rapid spanning tree is going to be for per VLAN. When I have 10 VLANs, then I'm going to have 10 rapid spanning tree. Yeah. So all these things we are going to now focus. But before we get into that, we also need to learn something called BPDU code. Port first. We need to learn what? Port first. There is a big connection between the port first and the rapid spanning tree. What is the connection? Port first and rapid spanning tree. What is the connection? Let's go to our topology, then we will discuss on the connection between these two. If you see these 4 switches, not all the links in these 4 switches are connected to the other switch. For example, this link, is it connected to a switch? No. In this topology, only this 1, 2, 3, 4 links. Only these 4 links are connected to other switches. Only these 4 switches send and receive BPDU. Will any PC send BPDU? No. Can a PC respond to BPDU? No. They can't. They cannot respond. Only switches. Only switches can respond to the BPDU. PCs can't respond to the BPDU. So when a topology change occurs, every switch, what they do, they start sending BPDUs on all ports. Even when there is no change, every 2 seconds they send BPDU. Every 2 seconds they send BPDU. Now, when a change occurs, that BPDUs are very sensitive matter. BPDUs are very important matter. For example, when this is the primary path, if that link breaks, this switch will send BPDUs to all the link. This switch will also forward the BPDU to all the link. Now, for the BPDU that is coming from this switch to this switch, there will be a response. But will there be any BPDU response for the BPDU that is sent to the PC? No. PCs can't respond. But to decide on the roles, BPDU response are very important. Let's say this is blocking. To unblock this, wherever the BPDU is sent, the response should come. But it won't come. BPD is going, but there is no response coming. BPD is going, there's no responses. If no response comes, decision cannot be made. Switch will wait for these guys to respond, but they will not respond. They can't respond to BPDU. When a BPDU about topology change notification sent, this can respond because it's a switch. Switch understands BPDU. But this PCs cannot understand. This PC is like me. The switches are like my daughter. I went to buy one paint, what is it? Brush pen. It is called as brush pen. In my lifetime, I never heard this word brush pen. A pen with the brush head. You no need to touch that ink bottle, paint bottle. Paint will be inside that pen only. Color pen. And the tip will be brush. See what a technology. In my days, color pencil only my father will not buy. Crayons, you can't dream at all. So anyway, I went to buy brush pen. One big box I took. I thought that big box is what my daughter wants. The shopkeeper was saying something I didn't understand. I repeatedly asked him. Then my daughter said that he's saying that inside there is 5 pack. But I want only 1 pack, Dad. I don't want 5 pack. Okay. See? When the shopkeeper was saying in Kannada, there is 5 pack inside, I didn't understand Kannada. I was like this computer, I was not able to respond. My daughter said that there is 5 pack inside. I don't want 5 pack, I only want 1 pack. Oh. So that is the response, because she understands, she responds. I didn't understand, I can't respond. How a PC will respond to BPDU? PCs can't respond to BPDU. PCs can't respond to BPDU. So PCs won't respond. So this guy have to wait to take decisions. They have to wait to take decision. Even though the rapid spanning tree is faster, for rapid spanning tree to take a decision, everyone should respond. Otherwise, rapid spanning tree will also look like a small, slow spanning tree, waiting for response. And then PCs are not going to respond, and then timeout should happen. Only then rapid spanning tree can make a decision. Timeout. So it's same like golden spanning tree. 20-second timeout. To avoid this 20-second of timeout, we need to enable port fast. What will this port fast do? And where we will enable? I have to enable port fast on all these ports that connects to the end device. End device is nothing but the PCs, the servers, the printers, the end device or the edge device. Edge device cannot respond to BPDU. They are all edge device. Is switch an edge device? No, it's an intermediate device. Switch is an intermediate device. PCs are edge device. Now these edge devices, they are configured now. The edge device connected ports are now configured as port fast, meaning to take a decision, these ports need not to respond because they are edge ports. When you configure these ports as port fast, it becomes what port? Edge port. When you make the port as edge port, by default what it is? Point to point. You remember I showed you yesterday. Let me show you again. By default, if you check the ports, they will show point to point. You see, P and P2P, point to point. By default, they are point to point ports. Now, we don't want the port to be point to point because we don't have a switch connected. This is okay to have point to point. This is one point, another point, a switch. They can respond to BPDUs, no problem. But these ports need to be configured as edge port so that those ports will not be accounted during the topology change. Switches won't wait for those ports to respond to the BPDU. Switches won't wait for those edge ports to give a response. You should not configure these ports as edge port. No, you should not configure these ports as edge port. Because the response of BPDU here, it is very important. If you make these ports as edge port, then loop will occur. Why? Switches won't wait for BPDU's response from them. So edge ports are the ports that are connected to end devices, not an intermediate switch, end devices like printers, scanners, servers, computers, phones. So that switches need not to wait for the BPDU response. Without waiting for the BPDU response, they can do the role change. So by enabling port fast, I'm helping the rapid spanning tree to take a decision faster. Only then you can guarantee like 2 to 3 seconds convergence. If you don't configure port fast here, rapid spanning tree will take much longer. Yeah, it'll take like 20-second, 22-second timeout, something like that. So enabling port first will make the ports as an edge port. Edge ports are not considered to take a role change from blocking to forwarding. Let's go read now. Port first is a Cisco proprietary enhancement that allows edge ports to bypass the usual STP listening and learning state, transitioning directly into the forwarding state. So when you have port first enabled on the ports, no BPDU's response or responses are expected. So there is no need for listening or learning on those ports. They will be always in the forwarding state because they are connected to the end devices. Only the other ports, which is P2P, point to point, will be going through the different port roles. Now, you may have a question, port first is Cisco proprietary, then what about the other vendors? Other vendors, it is called as edge port. In Juniper, it is called as edge port. In many vendors, it is called as edge port only. Maybe this little word extra, edge link port or edge link, something like that. Cisco calls it the special name called port first. Right? Okay. Now, we are going to do this rapid spanning tree and test how quickly rapid spanning tree can converge. You remember we have already set this primary, secondary. I'm not going to disturb them. Let it be there. So according to what we have configured, I'm trying to explain this topology one more time. According to what we have configured, the traffic of VLAN 10, 20, 50 will pass through the upper path, meaning this is 10. 10 will go this path, and this is VLAN 20. 20 will also go this path, 50 we don't have. And then this one, this down switch will be carrying 30 and 40, down switch. 30 via down path, 40 via down path. This is what we already achieved, but what we have is a slow convergence per VLAN spanning tree. We are going to switch to rapid spanning tree. Now, let us go test. How I'm going to test? I'm going to disconnect this cable. If I disconnect this cable, what are the two VLANs in our topology will experience a drop? Say someone. If I disconnect that cable, if I cut the cable, will there be disturbance cost to VLAN 10 and 20? It's only 30-40, you have said right, because 30-40 primary is in the bottom path. These two will never get disturbed. Okay, keep this in mind. Now let me show you. Right now, when I say ping -t means don't stop, timeless ping 30002, this is keep on pinging. It'll be keep on going. Let me also take a VLAN 10 computer. This is also pinging. So now, as I said, I'm going to disconnect this wire. And now 10 will be pinging as usual, no disturbance caused, but 30 is not like that. It's already dropped. All right, 10 is still going. This clearly proves that they are all taking different path. And now you see how long this 30 takes to reroute. See, at least you will lose 5-6 packets for the convergence to happen. Already 5 packets gone, 6 packet gone. Around 50 to 60 seconds it will take for the convergence. You see, still the other path is not unblocked for this VLAN. Still the packet is not flowing through the upper path. It is because timer based and only root switch can send the BPD. Now you see, it's pinging. Okay, I'm going to put the wire back. Again, you will lose some packets for reconvergence. At least this time 4 packets you lose, 3 or 4, let's say. Because this time it won't wait for timeout, but other 15 to 15 seconds, 2 15 seconds, 30 seconds at least it will take. 3, 4. Last time how many packets we lost? More than 6, 7, 8, 9. This time 5 packets. So what I'm trying to say is this is slow. We are going to enable rapid spanning tree and we will do the same test again. Now, these ports, I'm going to make it as port first. That is very important. So 03 to 06, make it as port first. How to do that? See. Interface range F0/3-6. Am I right? 3, 4, 5, 6. Yes. See? Spanning tree, port first. This is the command. This command will make those ports as edge port. I don't know simulator will show you or not, but the real device will show you when you go to these ports, it will show you as edge port. The simulators may show you as P2P when you go and check. Sometimes it may show edge also, but the real device shows it as edge port. Now when I hit enter, when I have not said enter, but when I say enter, you will see a big warning message. It is what? Warning. It is not an error message. It's a warning message. That warning will say, be sure that these ports are not connecting to hub or a switch. What does that mean? This port first should not be enabled on the link that connects to the hub. That is what it is. So don't take this message as very serious message. This is saying, make sure it is not connecting to another switch. Make sure it is a non-trunking port. Make sure it is not between the devices like hub, bridge, switch, consider what is it? Concentrators. Okay, it's just a warning. All right. So now next, let me also go to this switch one and make these ports as port first. What are the ports now in 0306? Spanning tree port first. All right. Now let us now go and check whether this shows us edge. I want to check for VLAN 30 F0/6. Spanning tree for show spanning tree for VLAN 30. F0, okay, 5, F05. Yeah, F05. F05, this is what I was telling. In the real device, it will show us edge. I already configured port first. It's supposed to show me edge, but it is not showing. Show spanning tree port first. Do I have the command? I don't have. Okay, now next is let's see this command. Show spanning tree interface F0/5. For VLAN 30, it says I'm forwarding, but I made it as an edge. In the real device, it will show edge. All right, now it is ready for rapid spanning tree configuration. You see, the rapid spanning tree configuration is very simple. One line command. This is the command. Spanning tree mode rapid. You see, when I say rapid, automatically this comes. In Cisco, every single VLAN will run separate rapid spanning tree. You don't need to separately enable. Even if you don't type this, you see, that's the only option you have. If you hit enter also, it is going to be rapid PVSTP only. Let me show you. Show spanning tree VLAN 30. You see, it shows rapid spanning tree. For VLAN 40 also you ask, it will show you rapid spanning tree. Show spanning tree details. You can see it is rapid spanning tree. Rapid compatible spanning tree protocol. And it is running for every single VLAN. VLAN 1, VLAN 10, VLAN, all VLANs, 20. Okay. Same way, I'll go to the other switches and configure rapid. Did I configure here? Yes. I'll configure on this one. Command is show spanning tree rapid. Sorry, not show. The global configuration mode, spanning tree mode rapid. I repeat on the other switch. Spanning tree mode rapid. On last switch, spanning tree mode rapid. Now, we have enabled port fast followed by rapid spanning tree. Port fast need to be enabled on all the ports that connects to the edge devices to make them edge. And rapid spanning tree has to be enabled on the global level, which we have done. All right, now all have turned green, which means they are load sharing. VLAN 10, 20, 50 is on the upper path. VLAN 30, 40, 60 in the below path. Let's go to 30 PC and see it started pinging now. Okay, it started pinging now. Focus only on this ping. These are all like when we were configuring, it took some changes. Even on VLAN 10, the changes might have happened. Let's wait for this. Still VLAN 10 is not converged. Let's wait. Once the convergence is done, then we can go test by cutting the wire. Show spanning tree VLAN 10. Rapid. Show spanning tree VLAN 10. Rapid. Show spanning tree VLAN 10. Rapid. So this is the path. Then why I'm not able to see the ping? What's wrong? What I'll do is I'll save the configuration and I'll load. Sometimes it happens whenever we do changing one algorithm to another algorithm. When you change the PVSTP to rapid, it happens. It's a simulator, not get stuck somewhere. So I'm going to save. Check one more time. Okay, it's pinging now. No, it's not. Let me try pinging 20. Ping hyphen T 20002. It's okay. Now I'm going to close this. Show run. 1 and 2 are trunking. And port first is enabled on 6, 5, 4, 3 interfaces. Okay, now let's do the testing. Once again, I'm going to ping from here. Ping hyphen T 10002. It's pinging. Now let's go to 30 computer and ping. We know that they take two different paths. Right? Okay. This 30 goes by the below path. You know that we set the priority already. And 10 is going with the upper path. Now I'm going to disconnect this wire. Which one should get disturbed? 30 and 40 should get disturbed. And I'm going to show you how many packets get lost. Last time, somewhere around 9 to 10 packets got lost. All right. Last time, 9 to 10 packet got lost. You saw that. But this time, sometimes not even one. I disconnected. Now you see. One packet. Okay, just one packet. In the real devices, sometimes you won't see even one packet lost. Now I'm going to put the wire back. I'm going to put the wire back. Not even one packet now. Okay, one packet again. Better no. In the per wheel and spanning tree, we were seeing like 9 to 10 packets lost. And here it's one packet. Let's disconnect again. One packet again. I put the wire back. Again, one packet only. But during this time, 10 never lost any packet because 10 is going with the upper path. Now let's disconnect the 10 cable, the upper path. I'm going to disconnect this. How many packet lost? One packet. Two? Okay, two packets lost. Sometimes it happens. Now I'm going to connect again. One packet lost. So better than per wheel and spanning tree. That's why it is called a fast convergence protocol. As it is said, it will take like 2 to 3 seconds. 2 to 3 seconds for this rapid spanning tree convergence. Any question on rapid spanning tree?